All right, so we need to turn this 3/4 inch 4140 pre-hardened rod here, and I need to put a center in the bottom. Before I need to face this off, I realize now that that's not going to do. Using my new inserts here that I showed a couple videos ago, these are seeming to get pretty darn good finishes on rough to finish materials, so I'm going to try it on the 4140 here. Quite a bit of stick out. So I need 1 3/4 inches. Yeah, that's a lot more stick out than I need. I'm going to readjust this. The total features are 1 3/4. I'll leave myself just around 2. This is a pretty high speed too. Actually, that's enough of a flat face. I think I'm good because I'm going to reduce this end part down to 1/4 inch anyways, which is going to be a bit challenging all by itself. So we're going to put a center. We're going to drill this for a center. Okay. So now can I even get in there with this insert? Ultimately, we're going to have a problem. Oh, I broke the insert off too. It did not like that interrupted cut. Yeah, it just broke the end right off of it. All right, ready to go. So I'm gonna use this insert because it reaches in better, because I've got to get this down to 1/4 inch ultimately, which I'm not even sure this one will fit, but I need to take this down to 1/2 inch right now. This might be a big cut. Let's try 40 thousandths. This pre-hardened stuff I'm getting a pretty decent finish on. Well, that's interesting. Hit a spot where better quality finish. But we're going to up the feed rate a little bit to speed this up so we can move this material this week. Give you a much better finish too. Weird. I think we're done with one side. Now we have to figure out how to get 6.9 inches on the middle, which I'm not sure how to do. All right, so we flip this guy around. We're gonna do the same thing on this side. We're basically going in 1.5 inches. I'm gonna call that good. All right, here's our shaft to this stage. Next up, we gotta cut a slot in the top of this guy. Any part actually, because we can make that the top later. And originally I was gonna go straight down and just cut an 1/8 inch slot, 1/8 inch wide, 100 thousandths deep. The needles themselves are about 94 thousandths, so would be underneath the surface. But then I thought about it, and when this thing spins 120 degrees like this, and it does it fairly quickly because that rotary actuator is pretty strong, it would throw the needle out, and it likely wouldn't end up where I want it to. So instead, I'm going to cut this guy at an angle. And how do I cut a 1/8 inch wide slot at a 30-degree angle? And that becomes a little bit of a challenge. So the easy part was, how do I get 30 degrees? Well, either I could raise the vise up 30 degrees, or I could nod the head on the mill 30 degrees. But then, how do you find the center? And I want the center of the 1/8 inch slot to be right at the top. And that's actually quite a trick. So I thought about several solutions, and here's what I came up with. So the first thing is that finding that center would be very difficult. I need something like a tooling ball. And in order to use a tooling ball, I would have to drill a hole in this guy and mount the tooling ball so that I could have two parallel points that are equidistant from the center on a 30-degree axis, because otherwise there's no easy way to do it, at least that I could think of. However, what I did find was, if I take and I move the mill, so here's top dead center, let's say, if I come this direction a certain distance, it'll be the equivalent when this rotates and makes that top dead center of cutting a 30-degree slot. So that's what I'm going to do. And that's kind of an interesting trick. So hopefully I can make that clearer when I get over to the mill and cut this slot. Trying to set this guy up reminds me that I need to make another tool one of these days. So right now I've got a 1/2 inch parallel in here, set down the center. And this gives me 3 points of contact, but it's not ideal for me. It's not making me completely happy. I'd rather have a really narrow V-block, so I need to make one of those so I can hold small stuff in the vise. Because if I use a large V-block, then it's hard to press on this. You'll have to put some spacers or something going in sideways to actually press on the sides of this. So a small V-block would be really handy. I'm also shifting it over this direction because I wanted a place where I can get my indicator down here, my electronic indicator, to find center, because that's the first thing we're going to do. We're going to find the midpoint of this, which will be the high point on this guy right here. So I'm just finding the center between these two spots, dividing by 2, which will give me the high point, which is where my reference measurement is. Wow, that's perfect. So this would be dead center right here. So if I cut the slot here, it would be perfectly square. So let's show you what I was talking about. So if I want the equivalent of a slot angled this way, all I need to do is cut off center 0.1875, which is 1/4 the diameter. We're talking a 30, 60, 90 triangle can be generated here. So it's 1, 2, square root of 3. That's why this is half the radius there. It's not an accident. If I cut a vertical slot right here, when I rotate that back 30 degrees to make the center of that slot top dead center, it will be angled at the 30 degrees. Same if I want it the other direction. And works perfectly every time. I tried it in CAD just to verify my suspicions, and it is correct. So now I need to get an 1/8 inch end mill and see if I can reach down and cut where I need to cut. So to hold the 1/8 inch end mill, rather than use an R8 collet, I'm going to use this board carbide holder with the world's smallest set screws in it. Look at, there's 2 set screws there. Uses this teeny tiny Allen wrench. The advantage is I can push this all the way to the bottom. So if I break the 1/8 inch end mill like I've done to pretty much every other one I've ever used, I'll be able to reseat another one, and it should have the same depth if everything's correct. I guess if the manufacturing process is identical, because once I cut this, it might be difficult to find the top dead center from setting my depth again. All right, so I'm going to set this 21 thousandths feeler gauge here, and I'm going to drop the quill until it's got decent contact, and then I'm going to set my Z-knot, my height for 0. I'm going to pull this out of here, and I need to come back down 21 thousandths and reset my 0. And that's my new 0. And that should just barely graze this guy, which I've got it 2/10 under, so it's not, but it looks really good. Yeah, that looks good. Okay, now my reference point is 0.1875. Yeah, it's this one, so I want it to catch. So when it rotates this way, I need to go 0.1875 towards the rear if this is the left side. So we want to go back 0.1875, and then my total depth I calculated based on the top of the circle, or the cylinder, as I did here. So I need to go down a total of 0.1714, and that should be a perfect depth. So for part of this depth, because I set my depth based on this top, it's not even making contact. So I got to go a decent distance before I even start to make contact here, like somewhere there. And that's almost 20 thousandths. So that helps. And we want my speed as fast as I can go, because it's an extremely small end mill. I learned that lesson a while ago. So when you're using tiny end mills, you want to have maximum speed. If this thing could do better than 4,000 RPM or 3,800 RPM, I should probably use that, but it can't, so we're going to use what we've got. Oh, there's 4,200. Okay, so we'll use that. I've increased the feed rate a little. I'll take a shallower depth of cut, but go faster. As you can see, I didn't plot the 1/2 inch because I didn't even think about that in that drawing. It's going to start to cut into this 1/2 inch portion here. I might have to plunge down with this instead. Last pass. Plunging down to final depth. I'm going to take this last pass slower. And I use the vacuum to get chips so they don't get stuck in there. So quickly going to deburr this. I can't deburr the outside, but I can get the inside so I can do a test. Gotta be careful, I'm hitting my vice jaw here. It's kind of close. Yeah, that's much better. It was really sharp. Because I won't be able to change the depth if I take this out, and it'll be very hard to find this position again. Yeah, that's below the surface. It definitely fits in between here. And it looks like this thing's going to be rotating this way, and it looks like it'll cup it nicely. That was the whole point. Let's see if I can zoom in and show you. Hopefully you can see now that it's a little cleaner, that there's a cup on this side. So as this thing spins, what I'm hoping anyways, is as this thing spins this way, this needle will slide to the back. Let's see if I can get a piece of shim stock to force that back. There's a little bit of clearance here. So as this thing spins, this is going to slide towards the back, and hopefully that will prevent it from flying out of here. Now let's just see if I can. So I'm pushing back. I'm just pushing that direction now, and you can see I can't pop this guy out because it's in a pocket. So I'm hoping as this thing rotates, it'll sit in that pocket, and then when it comes out the other side, you see it just pops right out because that's going to be downslope. So this side has nothing to hold it in. This side has a pocket. Next up, I got some 1/2 inch tooling plate here. This is going to be the catch. So I'm going to make the needle catches here, both sides at the same time, because I got to remove a 1/4 inch of material out of here and just leave a little 1/4 inch lip down here. Not a super precise operation. I'm only grabbing about 1/8 of an inch of material here, but I got it pretty tight. Yeah, hopefully, we'll see. Gonna make one hell of a mess. You'll notice this transition. Well, on the other side, you'll notice the transition where the cutter moves in the two positions. The cutter loads differently depending on how much material it's cutting, and it doesn't cut the same. So you end up with a transition that's maybe 1/1000th difference, and you can feel it just slightly as you transition over, which I will have to fix. I will take the last couple of passes as very light passes. Yeah, I can feel that. So, and I checked my mill, and the tram is good, so it's not a tramming issue. This is 5,000 steps of cut. And I'm trying cutting in a different direction, see if it makes a difference. This isn't a precise thing, but it's a good opportunity to learn, so that's what I'm doing. And it kind of looks like the finish is better cutting in this direction. So we're going to do it. Yeah, it's a couple tenths. I can feel it. Just barely. It's amazing how sensitive one's fingers are. All right, so now this will be my two pieces. I'm going to cut this in half, All right, so I've scored a line down the center of this, roughly the center with the calipers. This is only aluminum, so I'm not going to damage the tips. I've got about 30 thousandths aside I can take off after to square this up. So we're going to hop over to the bandsaw, cut this in half, and I'll be right back. Now I'm just going to side mill these two sides to fix the saw cut and just clean that up because it's kind of ugly. Although these were pretty straight cuts, I was pretty pleased with that. But we definitely need to clean them up. And I'll bring you right back. You don't need to see this, I think. Alrighty, I got a bunch of parts here. First thing, I got to press these bushings in both these sides here. So these are nylon, and one needs to go in each side flush. So I'm going to pop over the arbor press real quick, press these in, I'll be right back. Okay, press these guys in. Now we need to mount these guys, and it's pretty easy to tell which one goes which place, because here is the catch, here is the this one, here is the part that catches the parts, and it sticks out the front away from this base so that it has plenty of room for the robot arm to get in there. So let's put in this side first, and this would be the front. So let's just get a couple screws in here. I'll tell you, I'm a bit spooked about this whole project because it's one of those things where I have no tests in to see if this will work. I made a bunch of educated guesses, and if I was wrong, then I'm gonna have to remake some parts or find some way to fix my mistakes. And that's the world of prototyping, so I knew what I was getting into when I started this. I guess at this point, I can't put the other side on yet because that's gonna capture the shaft here. And so I think what I'll do is I'll put these guys in first. There's not a lot of slop, so I took a lot of care in getting my measurements precise. I hope that works out. I think shorter screws would have been fine. These are 1 inch. I think 3/4 would have been plenty. Okay, that looks about right for the needles, so that's a good sign. Then this guy fits in here like so, and that looks like that is correct. That looks good. You can see down in there, you can line that slot up, so that looks good. Let's put one of the parts catchers in, and I think I'm gonna go get some shorter screws. I'll be right back. Okay, I guess now I can put the shaft in and then screw on the other side. That's a little disconcerting. Okay, well, it's all fitting so far. My measurements seem to be correct. Yeah, well, let's just for the heck of it see if I can get these started. It's a good sign they line up. So remember I said these 1/4 inch plates were a little bent. You can tell because I had to pull this one down because it should have been exactly flush with the top and it was sticking a little proud, but I couldn't get the screw started either. So good sign that they mated together nicely. Let's see, this guy goes here. Okay, 2 screws on the bottom, which have to line up with my mess up here. So I can't use the first hole, I have to use the later one, but at least it lines up. That's good. Well, that's a good sign. Everything's lining up. Okay. Now based on the direction the motor goes, oh, well, there's my first problem. Something's too tight because I can't rotate this shaft. It's very tight. So probably what I need to do is to take a little bit of material off of one side of it because it's pushing in the bushings too hard. I made it really close and tolerant, so I just loosened the 4 screws that hold this plate, and now it rotates freely. So all that means is that we were really close, and we need maybe a couple thousandths off. That's it. So I guess I should pull off one side of this, remove a couple thousandths off of the 3/4 inch part of this, and then come right back. Or I could shim this part, because if I tighten these down, I mean, that's not pulling in hardly at all. Yeah, now it's stuck. All right, I'll be right back. Alrighty, so we got this so that it moves freely now. There is a bit of friction, that's the nylon bushings. There's a tiny little bit of play now because I took off, first I took off 2 or 3 thousandths, that wasn't enough. Then I took off another 2 or 3 thousandths, and then I took off another 3. So we're almost 9 thousandths in, 8 or 9 thousandths in, and it's almost no slop, but the nylon bushings are kind of tight. Hopefully they'll wear in.